So for example 3, you are going to need to use your graphing calculator. There is a sine inverse button. If you hit the second button and then you hit sine, you can find the approximate sine values. We say approximate and not exact because we're going to have to round them. And let's round them to 2 decimal places. So if we're in our calculator, we push the second button, push the sine button, that gives us sine inverse. If we substitute in 1/3, that's going to give us 0.34 if we round to 2 decimals. If I have sine inverse of -1/4, that's going to give me 0.25. And it's important to note that, remember, our range for a sine function, our domain for our sine inverse function is from -1 to 1. So the values that we're substituting in have to be in our domain. Next, we have to take a look at the composite property of functions. Let's go ahead and fill in these blanks. So if I have f inverse of f of x equals sine inverse of sine of x, that's going to equal x, where negative pi over 2 is less than or equal to less than or equal to x or less than or equal to pi. I'm not quite sure why these values aren't showing up. If I have f of f inverse of x equals sine of sine inverse of x, that's going to equal x, where -1 is less than or equal to x, which is less than or equal to 1. So they kind of cancel each other out. So let's find the composite of sine of sine inverse of pi over 9. So first we have to check, okay, is this in our domain of this composite function, pi over 9? Yes, it's between negative pi over 2 and pi over 2. So this is just going to equal pi over 9. The key when it comes to these composite functions is checking to make sure that your substituted value is in your domain. So if I want to find the exact value of the sine of sine inverse of -2.5, remembering that my domain in this case is between -1 and 1, this is going to be undefined, right? It's not in the domain. So this would be undefined. And go ahead, try, punch it into your calculator, see what happens. Next, let's take a look at the cosine function, right? And we're going to be able to find the inverse of the cosine function by restricting it over half a period, right? So here I have cosine of x, right? It goes from -infinity to infinity, and its range is from -1 to 1 inclusive. That means that's going to become the domain of our cosine function. So now I have a domain from -1 to 1, and we restrict it to 1 half a period, right? So it will pass the horizontal line test, and that gives us a range, right, from 0 to pi. So for cosine, our range is from 0 to pi. Sorry, for cosine inverse cosine. But for inverse sine, remember it was from -pi over 2 to pi over 2. We do need to keep those pretty clear. Here's our cosine function restricted to half a period. And here it is graphed with its inverse. So here we've got our inverse cosine, and here we have our cosine. So let's use our unit circle to find some exact values of our cosine functions. So if I want to find the exact value of cosine, remember that cosine of theta is x. So I need to look between 0 and 100. 0 and pi, right? I only care about the top half of my unit circle because that's where this function is defined. Where is their value of 1/2? So where does x equal 1/2? Well, that's going to be at pi over 3. That's where x is 1/2. So our answer would be pi over 3.